Yes, good afternoon, everyone. Our computer networks are great. I have to discuss about the introduction about the computer networks. And also, I have to cover some one of the unit of our syllabus. That is, we are having a number of different OSI reference layers are there. That is the 7 layers. So I need to give some explanation about all the OSI reference model, and also I need to cover some topics from our subject. So according to the syllabus, we are having that physical layer and data link layer, network layer, transport layer, and application layer. So there are 5 units are there in our syllabus. So before going to discuss about each and every topic of our computer network, what is the use of the computer network, where we are implementing the computer network? So name itself, what is meant by network? So network, what is meant by network here? Network is nothing but it's we have to connect the number of different places for the getting of result. So in our case, computers are going to be connected, right? Exactly that computer network means here computers are going to be connected for the transmitting of the data from one user to another. Nowadays, everyone is using that internet. So based on the internet, we can transmitting the data from user to user. So computer networks is nothing but we have to send or share the data by using a network connecting of the computers. That is nothing but internet. If simply that network is nothing but connecting a number of different places or number of different users. That is nothing but we can connect the transmitting for the purpose of transmitting the data. So here computers are going to be connected for the transmitting of data or sharing of information. That is nothing but computer networks. So for the networks, connecting of networks, we can use a number of different hardware related components. So in that hardware related components, it may be routers, switches, and different type of different purpose related hardware can be used for the transmitting of the data in a network. So, so before going to discuss about each and every topic of the computer networks, so every networks are either we can transmit by using of a wired or wireless. So the meaning of that, so we can transmit the data by using of a computers, either we can connect or without connection. Either we can connect or without connection means here, we can directly connect by using of a wire and we can use without wire. That may be either a Wi-Fi or any other different kind of transmission. So that wireless, we can call as a wireless. So either we can use wire or wireless. And also we have to use these words like a guided medium and an unguided medium. So if you are transmitting the data by using of the wire, so that is a guided medium. The transmission of the data by using of a wire, that is a guided medium. If we are sending the data by the transmitting of the data without wire, that is a unguided, that is a wireless. So why? Because the differences means here, if you wanted to transfer the data within the area, that is a local area network, that's the shortest size of the area. So we can use a wire. If you're transmitting the data from one system, which is located in the another system, that is in a other country. So it's not possible to connect by using of the wire. It's not possible to connect with the wire. So that's why in this case we need to implement that wireless connection, wireless transmission. So for that we are having the two types of medium that we have to send from one system to another system. That is about guided. If we consider the guided medium, we are having that wire, three types of wires mainly, especially coaxial cable, um, in- twisted pair, right? So these are the different kind of wires can be implemented in a wired medium. And the right side of it, that means unguided medium means without connection, you can transmit by using of a infrared wave. Uh, these are different kind of waves like infrared waves and some different kind of waves can be implemented, right? So either we can implementing the data, sorry, implementing that connect without connection, the transmission wireless, right? So uh, based on the guided or unguided. So if we wanted to transmit the data by using of the wire, we can transmit any one of that. So it is possible for only the shortest distance. So based on the distance, we can categorize the three different type of networks. Networks is have to either it is based on the size, local area network, that is about land. We can also call it as a land, local area network. If we are implementing that size more than the local area network, that is more than that land, we can implement that WAN, wide area network. For example, the wire is used in between of the computers for the connecting of a number of computers in a single lab that we are implementing the wire by using of the local area network. One group of computers can be connecting here, and another group of the computers are going to be connected in some other different distance. It is in the other area. So we can't connecting by using of the wire. That's why we can implement by wireless. So here that one local area network and another somewhat more than that local area network range that will be implemented by using the wide area network. So these wide area network and that local area network we may connect with the using of the wireless, right? So that's why the number of different kind of equipment that are implementing to connecting a wireless network. Right. So these are related to that some concept of wire and wireless, and based on the area, local area network, wide area network, and here in this between this local area network and wide area network, we are having one more metropolitan area network, right? So here, this is about that how the components will be connecting for the transmitting of the data. If you are transmitting the data for the sender to receiver and the receiver to sender at the same time that we are called as a full duplex data transmission, right? So here that we are having the three different type of data transmission modes are there. One is half duplex, the second one is full duplex, and third one is simplex. Here we can also, based on that, simplex, half duplex, full duplex. We can call like it is a simplex, half duplex, and full duplex. That means here simplex means here the data can be transmitting from the sender to receiver. Only sender to receiver. The receiver is only accepting the data, right? That is about the mode of simplex. But here that second type of that one, half duplex means here, the sender is going to transmit the data sender to receiver, and also the receiver is going to send the back to the sender. That is either sending or receiving. That can be possible at a time. Means the sender is sending the data to receiver, or receiver can be send the data back to the sender. That only that one way is possible by using of half duplex. So a one way means here by the sending or receiving is possible. Sending or receiving is possible for the transmission at a time. That is about half duplex data transmission. And third one is full duplex. Here the full duplex means here we can transmit the data and receive the data both at a time. The sender is going to send the data at the same time. The sender is also receiving the data. That means here sending and receiving both can be possible at the same time. That is about full duplex. So like that, simplex, half duplex, and full duplex, these are the modes of the transmitting of the data from sender to receiver, right? And also we are having that based on the communication, either it's a one-way communication or two-way communication. So both will be implementing at the same time, but it's a full duplex mode, right? Full duplex. So the architecture, each and every device of that computer-related hardware is going to implement that uh, one reference, basic reference. That here that every computer organization is going to be implement that OSI reference model. OSI reference model. One reference model is there, that the basic one. That means here OSI reference model is there. Yeah, we are having that OSI reference model. That is one of the institution, that is the ISO, International Standard Organization. is going to be implement that OSI reference model, open system interconnection model. For each and every component of the computer is going to be implemented by based on the particular OSI reference model. So the communication can be done by using of this one. For example, if we are having one holder, that electrical holder, that a bulb holder. So the bulb holder, we can insert any kind of the bulb in the particular holder. The company, if even though the company is different, the holder company is different, and bulb company is different. Even though we can insert that bulb into the holder, why? Because the holder and the bulb manufacturer companies have to maintain some rules and regulations for that. So then, if and if any one of the bulb can be hold that holder. So that's why in that computer organization, each and every hardware component is going to be implement the same architecture based on that OSI reference model. Then it is easy to communicate. Any device can be communicated by using that. So that OSI reference model is a basic model for the any organization, computer organization components, right? So that international standard organization is going to be implement this OSI reference model. Based on the OSI reference model, we are having that uh, 7 layers, right? 7 layers. So I will explain what about that 7 layers here, and how we are going to implement that. I will share one layer. Yes, yeah. That mainly that open system interconnection, that OSI reference model is having that 7 layer. The layers itself from the top to bottom, we can read out that it is exactly application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. So, right, in the case of this one, we are having the 7 layers in the OSI reference model. OSI reference model that we are having 7 layers. That each and every component can be structured, it's organized, these 7 layers. So either if it is we are having some advanced compared to this OSI reference model, that is about the TCP IP, transmission control and the internet protocol, transmission control protocol and the internet protocol that we are going to implement. So in that, the basic OSI reference model, how many number of layers? The 7 layers are there. The 7 layers are going to be implement the same TCP IP, but the concept here, the OSI reference model is having the application, the presentation, and the session. These three layers are going to be used as a single layer in TCP IP. That what are the different differences between these two means here? OSI reference model is having the 7 layers. The top 3 layers are called as the software layers, and the bottom 3 layers are called as the hardware layer. That means here that application layer, presentation layer, and session layer. These 3 layers are called as a software layers. These 3 layers can be going to be implemented in a TCP model as a single layer. The name is application layer, and the transport layer is there in that it's the heart of this OSI reference model, that is about the heart of the all the layers, that is about transport layer is the heart for OSI reference model, that is a state in between of the hardware layers and the software. The bottom layers of the network layer, data link layer, and physical layer, these three are called hardware layer. So the hardware layers itself, it is in that network layer is implementing as a internet layer in the TCP IP model. And the data link layer and physical layer is going to be implemented as a single layer. The name it is network interface, or also we can call host to network layer. So what I'm saying here that the basic model of the OSI reference model is going to be implemented as a TCP/IP. If that TCP/IP is having the layers mainly, and the 4 layers, the application presentation session is considered as a single layer, and the transport layer is also, which is a transport layer. Network layer is going to be implemented as the internet layer, and the bottom physical layer and the top data link layer. These 2 layers can be implemented as a network interface layer, or also we can call host to network layer. So before going to discuss about that architecture of the OSI reference model, so how that application layer, session layer, presentation layer, transport layer, network layer, data link layer, and physical layer. So the user can access that application layers only. application layers only. That the presentation layer, transition layer. Here, these are the from the bottom to top. There is the application layer is going to be send the data at the side of the sender to the presentation layer like that. So the each and every components can be used in our networks. In our networks, like the data transmission can be possible in that in the way of yeah, here that OSI reference model is having that 7 layers. The bottom to top, that's a physical layer, data link layer, network layer, right? So bottom layers are hardware layers, and the top layers of uh, is called as a software layer. So next, what is the point here? The physical layer is there. That physical layer is going to be connected directly to the wire. If we are using that wire or wireless, the physical layer is going to transmit that in a data in a form of bits. So the bits can be transmitted from the physical layer to through any wire or wireless to the physical layer of that sender side to receiver side. What I'm saying here, that physical layer is directly connected with that physical layer by using of a wire or wireless. So the data transmission can be possible in a way of bits in a physical layer. And the second one is the data link layer. In the data link layer, the data is going to be considered and that will be transmitted in a form of frames. Frames. If we consider the right side of that we said receiver side, the physical layer, what the physical layer is receiving, the physical layer is receiving that connected wire or wireless data in a form of bits. So that is going to be transmitted side of receiver, the in a form of frames. The bits are going to be transmitted, or the bits are going to be covered with that frame. The frames are going to be transmitted to the upper layer of the data link layer. To the side of the receiver, the data link layer, what that is received in the form of frames, that is going to be sent to the network layer in a form of the network layer is going to be transmit the data in a form of packets. So the data in a network layer that will be transmitted in a form of packets. So the packets are going to be transmitted to the transport layer at the side of receiver. The receiver side, the transport layer is receiving that information from the network layer that can be transmitted in a form of segments to the upper layer. Upper layer means here the session layer, presentation layer, and the application layer. So like that, finally, session layer, the presentation layer, and application layer. Application layer is going to be implement that to the display the content what that exactly receive. So here, physical layer is responsible for that transmitting of the data. Here, physical layer is the transmitting the data in the form of bits. So the each and every part of that data, here the data link layer is going to be responsible for sending the data from sender to receiver, that is the data link layer, only node to node responsibility. That means your network layer is going to be implement that either it is a host to host response. The transmitting of the data in a form of packets and also the responsible for the transmitting of the data to the host. So number of different devices are going to be connecting in a devices network. So the meaning of that the network layer is going to implement that host to host delivery. But here the transport layer is the heart of that will be responsible for that data transmitted from application to application or process to process. We can also call it the end-to-end response. End-to-end response. So this is about that brief this introduction about that OSI reference model here. Now I have to explain about that concept of transport layer, right? What is meant by transport layer? What are the design issues of the transport layer? Right? The transport layer, that is the heart of that OSI reference model. It is going to be responsible for that end-to-end transmission. End-to-end means the process is going to be delivered to the end. That is about destination process. So one computer is going to be run number of different kind of applications, number of different kind of applications. So our intention, the transport layer is going to responsible for that uh, process to process delivery. What are that means here? One device is having a number of applications means uh, some we are having an application of WhatsApp, some Facebook, some other different applications are there in our phone, mobile, right? So when we are sending some information through WhatsApp, that receiver is also receiving the same message through the WhatsApp only. That is about transport layer is going to be responsible for transferring the data from application to from the destination to the application of a sender. So application sender to the application destination. So that is the end-to-end process delivery. So for that we are having the transport layer number of different services. What are the services that are provided by these transport layer? So that transport layer is going to be used for that establishing a connection in between of the sender and the receiver if we are using that connection, and also addressing one of the addressing we can transmit that data by using of that address. What is meant by address here? It is each and every host on a network is having IP address. That address of the host is nothing but an IP address, and some different kind of applications are going to be run on a system. That is about application address is nothing but port number. So the port number and the IP address both will be considered as a single, that is a socket address. Socket address is nothing but the socket address is nothing but port number along with that IP address. IP address is going to represent by the system address or a host address, and port number is the application of a particular system which we are running on the system. That is the application address. So the socket address here we are going to implement that IP address along with that port number. That is about socket address. So here that the transport layer is going to be used, that connection is going to be established. That is about connection management is the one of the service. Management means here we can send the data after the completion of the connection establishment. So for this connection management, we are having a three-way handshake. Three-way handshaking is going to be implemented if it is a TCP, transmission control protocol. Otherwise, we can implement the user data protocol without connection. So the meaning of that, the transmission control protocol or the user data protocol is going to be implemented either with using of connection or connectionless. So if we are implementing the connection, that can be used to TCP, transmission control protocol. If we are implementing the connectionless transmission, that is the user data protocol. So in this one, when we are implementing the TCP, transmission control protocol, that connection is going to be established by the three-way handshaking. So means that the client is going to send the request for the connection. There is server side, server is received and that will be sent as a response to the client. And after the sending of a request, getting the response, that acknowledgement will be sent. That is about to the destination, that is server. After these three, hi, hello, okay. This after these three statements, the data is going to be transmitted. After the completion of the data transmission from the sender to receiver, the connection is going to be terminated. The connection is going to be terminated. That is nothing but a terminate the connection. So here that connection transmission control protocol is connection oriented and the user data protocol is nothing but connectionless. So establishing, maintaining and releasing of the connection, that is the responsibility of the transport layer, and getting the address of the application along with this socket address. Socket address includes that IP address and port number. That is the address. Then data transfer, flow control. Again, that one more, the flow control is there. Control when what we are using that flow control technique that we are going to implement the transfer layer also, and error control related and congestion control. So right, we are discussed in the previous unit what we are, that is about network layer. We are having some congestion control techniques and quality of service. That is about shaping of a traffic data. That is the using of a leaky bucket algorithm and also token bucket algorithm. So like that, we are having some, these are the responsibilities of transport layer. The design issues also nothing but here implementing the services here. So this is about the connection oriented service by using of TCP, transmission control. If we are using the connection layer that we are implementing that by using of the user data control. So like that, we have to implement these are all different kind of services by the transport layer. So if we are using that TCP or UDP, we can use that connection or connectionless data transmission. So this is about the overall introduction related to the OSI difference model and also that transport layer services and some connection management related and also transport layer concepts. Thank you. Thank you.